So in 9.4, we're going to introduce exponents into our expressions. So 5 times 5 is 25. Now, we are going to say number 2 as 5 squared. It is 5 to the second power is the other way to say it. You cannot say 5 2 or any 5 power 2. None of those are good. It's 5 squared or 5 to the second. And we're going to say it as 5 squared. And 5 squared is 5 times 5. It's the same answer, 25. The next one we're going to say as 5 cubed. 5 to the third power is 5 cubed. And what does that mean? It means 5 times 5 times 5. We're multiplying here. We're not adding. It's not 15. It's 5 times 5 is 25 times another 5. What's 25 times 5? Well, if I send you to the store with 4 quarters, you've got $1. If I send you to the store with 5 quarters, you got $1.25. This is 125. We're also going to do exponents. So these little numbers are called exponents. Okay? And they tell you how many times to multiply the number, the base number, the big number by itself. So this is x times x, which is 4 times 4, which is 16. This we're going to say is x squared, and we would say that as 4 squared. 4 squared is 4 times 4, also 16. We're going to say this one here is x cubed, and that's 4 times 4 times 4, or 4 cubed. 4 times 4 was the 16, and then 16 times another 4. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. 4 cubed is 64. Right? So once you get past 3, you just say to the 4th, to the 5th. This is 6. You would say this as 6th. It's not 6th. 6 to the 5th. All right. Exponent is using ordinal numbers like denominators of fractions. And this is the base you say is a normal number. 6 to the 5th. You don't have to say the word power. 6 to the 5th. All right. So let's understand the parts of this. All right, so let's copy the powers. So the whole thing is called a power. Even though you say y to the 4th power, the whole thing is the power. The exponent is the little number. So we're circling the exponent. And the base, the word base means bottom. The bigger letter or number, the base is, we're going to underline. All right, so this is y, and you would say this as y to the 4th. All right, so what is the exponent there? The exponent is 2. We're circling that. What is the base? -8. Okay, and you would say this as negative 8 squared. And those parentheses are absolutely necessary, and we're going to talk more about that, I think. Same thing here. The exponent is the 3. The base is the fraction 4/5. And this is 4/5 cubed. Right, so when you have a negative base and a fraction base, you're going to put parentheses around them. So that's 11 squared, which is 11 times 11, which is 121. That is 2 to the 5th, which is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. I'm going too fast. Times 2 is 32. Right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So notice we're multiplying 2 over and over again. That, by the way, is 10. That E was horrible. So 10 to the 1st. And what is 10 to the 1st? It's just 10. So easy, but sometimes it's skipped over and people don't understand what 10 to the 1st is. Evaluate the variable expressions. Now we have variables x and y, x equals 3. So x squared becomes 3 squared, which is 3 times 3, which is 9. Y squared, y is 10. 10 squared is 10 times 10, 100. Y cubed becomes 10 cubed, which is 10 times 10, which is 100, times another 10 is 1,000, right? And so on, right? We're going to do 10 to the fourth. You would add another 0 and get 10,000. And so on is how the powers of 10 work. All right, so here are the notes. So every time you see that, you're saying x squared, that's x cubed. Once you get higher than 3, you're saying x to the fourth, but truthfully, you can skip over the word power when you're saying them in class. Okay, so you would say that as 7 squared. That's all we're doing here. Yes, it's 49. You would say that as 2 cubed, which is 8. 2 times 2 times 2 is 8. You would say that as 1 to the fifth. So once we get past 3, we're using ordinal numbers, the order of a race. 4 people beat you in a race, you finish 5th. 1 to the 5th. Which, by the way, is 1. All right, so parentheses are absolutely necessary when the base is either a fraction or a negative. So let's evaluate this. That is negative 9 squared. That's negative 9 times negative 9, positive 81. And that's why I recommend you writing it out, because 2 negatives make a positive, and then you see the 2 negatives that are making the positive. Now, order of operations, we'll talk more about this, says exponents come before this. It's a negative, but it's just like subtraction. It comes before that. So this one is 9 squared 81, and then you make it negative. So most of the time in math, you mean the one on the left that I just circled. This is usually the one on the right. Students write that when they mean this one, and they actually write nonsense on their paper. Most of the time, you're going to be squaring a negative base. You're going to need those parentheses. So please, all right, you're writing these parentheses. They're not optional. So 3/4 squared would be 3/4 times 3/4. There's no canceling. You multiply across 3 times 3 is 9. 4 times 4 is 16. This one on the right is 3 squared. 3 times 3 over 4, which is 9/4, which is 8/4 is 2, so it's 2 1/4. Almost always, you're doing the one on the left. You need those parentheses. Okay, they're not the same. You cannot be lazy and leave out those parentheses when you have negative bases or fraction bases, the bottoms. All right, so what is that? So that's negative 5 times negative 5 times negative 5 times negative 5. All right, so there's 4 negatives. The answer is going to be positive. When you have an even amount of negatives, you have a positive answer. 5 times 5 is 25. 25 times 5 we did already, right? Which was 125, right? 25 times 5 is 125. Now we have to go times 5 again. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is, and this is positive 625. Okay. But if you wrote this, it would be negative. It would be 625, and you hardly ever want to do that. All right, so now 5/8 squared. So it's 5/8 times 5/8, which is 25/64. Negative 1/7 squared. So it's negative 1/7 times negative 1/7. 2 negatives still make a positive. 1 times 1 is 1. 7 times 7 is 49. That's 149. All right, so now here's one without parentheses. So this is 2 times 2 times 2 over 11. That's what that means. 2 times 2 is 4, times 2 is 8, 8/11ths. All right, so now for decimals, you do not need parentheses. You could put them, but it doesn't matter, right? Because, right, that is 2/10. That is 0.2. So this is 0.2, 2/10 times 0.2. So 2 times 2 is 4, but we have 2 numbers to the right of decimals. So we got an empty space there. Be careful of that. It's 0.04, 4/100ths. 0.1 squared is 0.1 times 0.1, 1/10 times 1/10. And so 1 times 1 is 1, but again, you got those 2 moves of the decimal point because there's 2 numbers to the right, and you get 1/100th. By the way, you could show this with fractions. Let's do that. 1/10 times 1/10, right, is 1/100th. 1 times 1 is 1 for the numerator. 10 times 10 is 100 for the denominator. It's 1/100th. You could have done the same thing for 2/10 times 2/10. So this is negative 6/10 squared. All right, so this is negative 0.6 times negative 0.6, right? We don't like an operation and a negative sign next to each other. So 0.6 times 0.6, we get 36. Move the decimal twice again, but this time we don't have to add a 0. And so two negatives make a positive. This is 36/100ths. This one, right, there's that, right? Nope, I forgot to write the parentheses. So you would do 0.6 times 0.6, right, and get the 0.36, and then you put the negative in front of it. That's negative 36/100ths. Most of the time, you're going to want to do the one on the left, though. So let's practice. What is the exponent? The 5. And you would say that is x to the 5th. What is the base? The base is y. Evaluate the variable expression for x equals 12. So 12 squared is 12 times 12, 144. Y cubed equals here, y is 6, so this is 6 cubed. 6 times 6 is 36, and 36 times another 6 is 216. Negative 1/11 squared is negative 1/11 times negative 1/11. So 2 negatives make a positive. 1 times 1 is 1. 11 times 11 is 121. That's positive 121st is how you say that. 0.4 squared is 0.4 times 0.4. 4 times 4 is 16. Move the decimal twice. You get 16/100ths. X is negative 3 here. So we have negative 3, right? So now we're writing the parentheses, and so it's negative 3 times negative 3 times negative 3 times negative 3. There are 4 negatives in this problem. It's going to be positive. 3 times 3 is 9. By the way, so you can once you write it out, you can multiply it in any order. It's commutative property of multiplication. You can multiply and add things. If they're all multiplying or all adding, you can do them in any order. So I'm going to do that. Right, negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is positive 9. 9 times 9, 81. If you do it the other way, you get 3 times 3 is 9, times 3 is 27, and 27 times 3 is also 81. But 4 negatives, an even amount of negatives, make a positive answer when you multiply. What's this? All right, so this is negative. I'm going to write it this way. 3 times 3 times 3 times 3. So this is negative 81. Right. We want parentheses unless there's a good reason not to. All right, so that's negative 8/10 squared. So that's negative 8/10 times negative 8/10, which is going to be a positive. And 8 times 8 is 64. Move the decimal twice. And so this is positive 64/100ths. All right, good luck on the homework.